Well, let's get started. What is science? We're going to have a lot of citations. Merriam-Webster, the state of knowing, knowledge, as distinguished from ignorance or misunderstanding. To the right, knowledge or a system of knowledge covering general truths or the operation of general laws, especially as obtained and tested through scientific method. Such knowledge or such a system of knowledge concerned with the physical world and its phenomena. Natural science, a system or method reconciling practical ends with scientific laws. Collins says, science is the study of the nature and behavior of natural things and the knowledge that we obtain about them. Do you see a running theme? Natural things, physical world. The careful study of the structure and behavior of the physical world, especially by watching, measuring, and doing experiments. So what are you seeing here? Observable, physical, and doing experiments. Let's see what else we find out. Science, any system of knowledge that is concerned with the physical world and its phenomena, which is the dependent variable, the observation, and that entails unbiased observations and systematic experimentation. And to the right there, the intellectual and practical activity encompassing the systematic study of the structure and behavior of the physical and natural world through observation and experiment. It couldn't be clearer, could it? Let's look at some of the branches of science and their subcategories. So you've all seen this picture somewhere, right? So you got the science tree. Now we're going to go into the subcategories. So you got formal sciences, social sciences, applied sciences, and natural sciences, and even subcategories of those. For today's talk, we're going to be focused on formal science and natural sciences. So formal science is mathematics and logic, concepts, right? Abstract, whereas natural is physical. Let's dive into formal science. Unlike other sciences, the formal sciences are not concerned with the validity of theories based on observations in the real world. Well, what are they based on then? What's the modeling all about? We're going to find out. Scientific modeling, the generation of physical, conceptual, or mathematical representation of real phenomena that is difficult to observe directly. Well, if you can't see it, how can you observe it, right? So if you don't observe it, you're going to model something that you can't see. Do you see the problem here? Scientific models are at best approximations of the objects and systems that they represent. They are not exact replicas. They're going to be abstract for the most part. Scientific modeling. In science, a model is a representation of an idea. I want the physical world. I don't want an idea. An object or even a process or a system that is used to describe and explain phenomena that cannot be experienced directly. Well, if I can't experience it directly, is it a phenomena? Models are a mentally visual way of linking theory with experiment. And they guide research by being simplified representations of a what? Of an imagined reality. Not phenomena, not dependent variable. Formal sciences, the study of formal systems such as those under the branches of logic and mathematics, which use a priori as opposed to empirical methodology. Formal sciences include mathematics, machine sciences, and computer science. A priori, a posteriori. Knowledge is obtained through experience, or knowledge is obtained by analyzing concepts independent of experience. What's empirical, originating, or based on observational experience? Relying on experience or observation alone, often without due regard for system and theory. Capable of being verified or disproved by observation or experiment. That's what I want. Or relating to empiricism. We're going to go into another field here called natural science. Definition. Any of the sciences such as physics, chemistry, and biology that deal with matter, energy, and their interrelations and transformations, or with objectively measurable phenomena. a science or knowledge of objects or processes observable in nature, as biology and physics, as distinguished from the abstract theoretical sciences as mathematics or philosophy. You see the abstract version there. The sciences collectively that are involved in the study of the physical world and its phenomena, including biology, physics, chemistry, and geology, but excluding, keyword, excluding social sciences, abstract or theoretical sciences such as mathematics and applied sciences. A science such as biology, chemistry, or physics that deals with objects, phenomena, or laws of nature and the physical world, natural science. Brings us to the scientific method. Definition. Principles and procedures for the systematic pursuit of knowledge involving the recognition, formulation of a problem, the collection of data through observation and experiment, and the formulation and testing of hypotheses. The scientific method is important because it is an evidence-based method for acquiring knowledge, unlike intuitive, philosophical, or religious methods for acquiring knowledge. The scientific method relies on empirical, repeatable tests to reveal the truth. Collins says, a method of research in which a hypothesis is tested by means of a careful, documented control experiment that can be repeated by any other researcher. That's what makes it great. The principles and empirical processes of discovery and demonstration considered characteristic of or necessary for scientific investigation, generally involving the observation of a phenomena, the formulation of a hypothesis concerning the phenomena, experimentation to test the hypothesis, and development of conclusion that confirms or rejects or modifies the hypothesis. You've seen these charts, types of variables, independent variable, dependent variable, control variable. What I change and manipulate is the independent variable. Dependent variable is what I observe. That's the phenomena. And of course, what I keep the same, control variable in the scientific method so that you get an accurate result. Everyone knows this is the way to prove cause of an effect. It's testable. You have an observation, your phenomena, the dependent variable. Your hypothesis is what you think is causing it. Then you test it by manipulating, testing the independent variable. It's either going to work or it's not. You may have to change your hypothesis, but you repeat until results are found out through an empirical method, not through abstract ideas, not through mathematics, not through concepts, not any guessing. You're going to know exactly what's causing the effect. Now, what do we have? Formal science is not testable. It's just math equations, concepts, abstract ideas. Take a look at this. We can summarize electricity, magnetism, and gravity into equations 1 inch long. And that's the power of field theory. And so I said to myself, I will create a field theory of strings. And when I did it one day, it was incredible. Realizing that on a sheet of paper, I can write down an equation, keyword equation, which summarizes almost all physical knowledge. How does a person write down a mathematical equation to the physical world? Well, the scientific method says, observe a natural phenomena, formulate a hypothesis, test the hypothesis via rigorous experimentation, modify the hypothesis, establish theory based on repeated validation of results. The actual method that the pseudoscientists use is make up a theory based on what funding agency manager wants to be true, design a minimum experiments that will suggest theory is true, modify theory to fit data, publish paper, rename theory, hypothesis, and pretend you used the scientific method. Defend this theory despite all evidence to the contrary. Pseudoscientists. What would real scientists say? Well, we know today's scientists have substituted mathematics for experiments, and they wander off through equation after equation and eventually build a structure which has no, what does it say? Relation to reality.
String theory come from, and who's the founder of it?
You're not going to believe this. In science, we always say that you make observations, you have a theory, you go make more observations, and it's a very, very tedious process. Wrong. Nobody that I know of in my field uses the so-called scientific method. In our field, it's by the seat of your pants. It's leaps of logic. It's guesswork.
There is a crisis in cosmology. Usually in science, if we're off by a factor of 2 or a factor of 10, we call that horrible. We say something's wrong with the theory. We're off by a factor of 10. However, in cosmology, we're off by a factor of 10 to the 120. That is 1 with 120 zeros after it. This is the largest mismatch between theory and experiment in the history of science.